Hello guys, welcome to Inside Electronics. So before moving on, let me remind you that this is a second part of another video. So if you haven't watched the first part of it, you can click the I button right here. It will take you there, or you can check the link at the description below. So in that video, I did a teardown of my battery pack, which is a 13,000 milliampere DIY battery pack, a 4-port USB one. Uh, the battery pack itself, I bought the case alone. These batteries are not included. I bought the case alone from eBay and I did a complete review about it in a previous video. You can check that out by clicking the I button right now. And you know, in theory, these 6 batteries and each of them are 2200 milliamp hour each. Now these are LG branded batteries. Nowhere it says on its own that it is LG made, but when I did a Google search for it with all the available numbers, and there are some uh, hidden numbers written over here, and when I did a Google search with all those available numbers, it came out that these batteries are made by LG. I got them from a laptop battery pack. I just repurposed it for a power bank. Now the reason why I did a teardown of my power bank is because I'm not getting a good enough capacity out of it. In theory, these 6 batteries, each having 2200 milliamps, should be 13,000 milliamps plus, and in theory that should be enough to charge my 3000 milliampere phone 4 times. Let's say 4.5 times. Let's ignore all the losses. Let's just consider pure theory. So 13,000 milliampere battery should probably charge my phone 4.5 times. And when the losses are considered, there are always some efficiency problems, and the boost converter circuit, there is a lot of losses happening there. The wire resistance, a lot of losses are there, especially when the boost converter, the power bank, does not have any kind of balancing circuit to monitor inserts individually. That was actually a cheap power bank. So yeah, I decided to tear down completely and to test each of these batteries individually. I charged them, I discharged them a couple of times under I used this USB charge meter. Now this is a really good thing to have, especially when you are dealing with a lot of batteries and 5-volt stuff in a regular manner. You definitely need to check out one of these. You can watch a full review about it up here by clicking the I button right now. So I use this to measure the charge and discharge rate of these batteries, and I will do another video showing how I check all these things. And when I measured the capacity of all these cells, the results were actually surprising. Out of these 6 cells, only 2 of them are somewhat good, and you may probably guess which are those 2 cells. They are right here. These 2 cells are the only survivors of the 6 cells, and these two, the 13, this one, I numbered them all. This one is actually 1600 milliamps, and this one, the 14, is actually 1500, roughly 1500 milliamps. So these two are the good cells in that pack, and all these 4 remaining cells, they are terrible. They are less than 1000 milliamps, and there is even one with 800 milliamps. I believe it's 9. Yeah, there it is. This one is 8000. Not 8000. It's 850 milliamps. This one, and all these 4 cells are below 1000 milliampere, and that's what causing the issue. Let's consider all these batteries once again. In theory, when all these batteries are connected in parallel, we should get a pretty good output, but no, that's not the case, especially when there is no balancing circuit and everything and anything. In reality, because there are 2 good cells, these 2 cells are connected in parallel with 4 bad cells. They are going to drain these 2 batteries down pretty quick. because they are of low capacity, they are going to discharge faster than these two, and when these are completely discharged, these still have some charge remaining in them. But because there is no balancing involved, the other circuit, the control circuit, what I actually see is an average value of all these batteries. So because of that average, because the average value will always be very low, the circuit cuts off even when the batteries have some juice left in it. And let's consider these two are will give around 3000 milliamps. Let's just add these for 1000 milliamps. So let's say these six cells are now only giving 4000 milliamps, and consider the losses in that this thing is only giving out less than 3000 milliamps. That explains why I cannot do a complete full charge of my phone. So I didn't actually expect that. I actually thought only one or two cells may go bad, but no, I was wrong. Four cells were bad, only two survivors. But yeah, that's how it goes. But I don't worry that much because I have lots of cells coming. I have one, two, three, four of these battery packs on my way right now, and I have a couple of more lying around on the other side of the corner, and you'll see videos about these coming up. And by the way, if you haven't noticed something, you are no longer seeing the power bank that I used in my previous video here, and that is because I sold it. Yes, I sold my old power bank. I sold it because I have ordered a different type of power bank, and it is on its way, and you will actually see a video about it, and you will actually see videos about me doing experiments with all these things right here in the future episodes. So I hope you uh, will like those videos, but that's it for now. Thanks for watching. See you in another video.